we're going to talk about how to use general purpose I/O pins in a Raspberry Pi. Now, we've already talked about this in the Arduino, so they're pretty analogous operations, except this time we're using Python, and we're writing Python code using Python packages that are built into the Raspberry Pi instead of the C stuff that we're using in the Arduino, or C++ stuff, the libraries that we're using in the Arduino. So, start off with this gpio.setup function. Now, what that does is it sets the direction, the pin direction. Is it an input or an output? Now, this is the same as the pin mode function in the Arduino. Same operation. So if you look at GPIO setup, it takes two arguments. First argument is the pin number that you want to set. Second argument is the direction. GPIO.out clearly makes it an output. GPIO.in would make it an input. So this is the type of thing you usually do once at the beginning of the program, right? Just like in the Arduino, when you set the pin mode, you would set that in the setup function, which would happen once. Now, let's say here we want to assign a pin value. GPIO.output, 13, true. So GPIO.output will assign a value to a pin. The first argument that it takes is 13 in this case, is the pin number that you want to assign. The second argument is the value you want to assign to it, true or false. Got to be binary. And that's the same as digital write in the Arduino, right? Digital write 11, high, same thing. So that's how you do this in Raspberry Pi. Now, so first we talked about setting up the pin direction. We talked about writing a value to an output. Now we also want to be able to read a value from an input. Oh, actually, first let's look at our example program, blinking LED, then we'll talk about the reading. So here's how you might write the example program. First thing we do at the top of the program is we import some packages. Since we're using the GPIO pins, you got to import rpi.gpio. We call it as GPIO. We're calling it GPIO just for convenience sake. Import time, because we want to do sleep operations in this, because we want to blink an LED, right? So we need a time package. Now we start off GPIO.setMode, GPIO.board. Now what that does, I think I already said this, but what that does is it basically tells you the pin numbering, okay? Which pin numbering we're going to use. Unfortunately, the Raspberry Pi has multiple pin numberings, and you just got to pick one. We're using the GPIO.board pin numbering, so that's how we set it. So fine. Then GPIO.setup, we set pin 13 to be an output, because presumably we put connected pin 13 to an LED. Of course, we'd put a little resistor in there so we don't blow the LED, but an LED. Now then, in our while loop, while true, so infinite loop, GPIO.output 13, true, turning on the LED. Then you sleep for 1 second. GPIO output 13, false, turning it off, and sleep for 1 second. So this is simple blinking of an LED. No big deal. So this is how you do it in the Python on the Raspberry Pi. Now, reading input pins. So we talked about how you drive an output pin. How do you read an input pin? So first thing, you got to set it to be an input. So you would say GPIO.setup 13, GPIO.in, right? That makes it an input. Then you can read from it and get a value, true, false value. So I can say value equals GPIO.input 13. GPIO.input is a function. It reads from pin 13, and it reads a value into the variable value right there, which is whatever true, false value it's reading, 0, 1 value is reading off the pin. Now, this is the same as like a digital read on an Arduino. Now, one thing about the Raspberry Pi is there's no equivalent to an analog read. So Arduino had an analog read, which would allow you to read an analog value off of a pin and assign a value from, actually I think it was 0 to 1023, assign that to a variable that corresponds to the voltage it read on the pin. That doesn't exist in the Raspberry Pi because Raspberry Pi does not have an analog to digital converter. So that's a limitation of Raspberry Pi, but you can do all the digital operations just fine.